Hello, AP Stats. Today we're going to talk about what we covered in class Monday or Tuesday this week. There was just a lot thrown at you, and I want to make sure you have time to practice these concepts and really feel comfortable with them. So, what I want you to do is take a look at this first question here. I want you to think about if this is a geometric or binomial random variable. Go through that acronym that we talked about in class. Once you've identified what it is, go ahead and work through parts A, B, C, and D. So what I'm going to do is I'm going to ask you to pause the video now and do that. And then when you come back, I will go through this question and you can see how you did. So in part A, the first lefty is the seventh person chosen. Well, I'm going how long until that first success. So I don't have a fixed number of trials. So this is geometric. If I think about the acronym BITS, you're left-handed or you're not. Each person being left-handed is independent of the next. T, number of trials until success. And S, the probability of somebody being left-handed, is constant at 10%. So if I define X as the number of people that I have to check until I get the first left-handed person, it's going to be 7. So my calculation would simply be, what's the probability X equals 7? It would be this 0.9 to the 6th power times 0.1. And I'm just going to show you in the calculator how you can do that as well. You can do a geometric PDF. That's just under second vars. The probability is 0.1, and we're looking for the first success on the 7th trial. So that's one way that I can do that. So let's go back and take a look at part B. The first left-handed person is among the first 4 people chosen. So now that means the first left-handed person could have been the first person, or the second, or the third, or the fourth. So this is really an inequality. So I really need to think about it in terms of what if the left-hander was the first person, the second, the third, or the fourth? Well, if the first person was left-handed, there would be a 10% chance of that. Plus, if the second person was the first left-hander, it would be 90% times 10%. They were not left-handed, and then they were. The third person, the first 2 would not be, and the third one would. And the fourth person, 0.9 cubed times 0.1. So that goes through the probability of finding that first success on any one of the first 4 trials. We can do a shortcut here. If I go to second vars and go to geometric now, CDF, 0.1 and 4, this is going to sum up the probability that the first success happens on the first, second, third, or fourth trial. So for us, it's a little above 34% chance that that happens. Moving on to part C. Would you be surprised if more, I think I did not type this correct, if we need to select more than 8 people before we find the first lefty? So what's the probability the first success happens after the 8th person? Well, this means it could happen on the 9th, 10th, 11th, 12th, 13th, 14th, etc. I can't calculate all those probabilities, so I have to use the idea of the complement here. So I need to subtract away what's the probability that the first success happens within the first 8 people. So it's going to be the same idea as part B. I'm not going to write that all out. What I'm going to do is write down 1 minus geometric CDF, P equals 0.1, and X equals 8. That's going to sum up the probability that the first success happens on the first or the second or the third or the fourth or the fifth or the sixth or the seventh or the 8th trial. So if I do 1 minus geometric CDF of 0.1 and 8, I'm going to get 43%. So this ends up being about 43%. There's a 43% chance that I'm going to have to check more than 8 people before I find the first person who's left-handed. Moving on to part D. What is the expected number? Expected number is just a synonym for the mean. So it's really asking what is the mean number of people that we would need to check before we find a lefty. Well, there's a formula for this. The expected value of X for geometric is just 1 divided by P. If we know that 10% of the population is left-handed, 1 divided by that, we'd expect on average we're going to have to check about 10 people before we find somebody who is left-handed. So hopefully that was helpful. That goes through geometric a little bit. I'm going to move on to question 2. So what I want you to do here, go through this scenario, figure out if this is geometric or binomial. Once you figure that out, pause the video and work through parts A through E, and then come back and I will go over it. So in number 2, a student passes 86% of their AP exams. The student is currently taking 6 APs. What is the probability that they pass exactly 3? Okay, so this is binomial. Here's why. If I check bins, they pass the AP exam or they don't. Passing one AP exam, we have to assume some independence here, assuming the likelihood of passing one has no impact on the next. The number of trials is fixed at 6. They're taking 6 exams, and the probability of passing each exam is 0.86, so that's constant. So we have a binomial random variable here. Say I define now y as the number of exams they pass out of 6. So y is the number of exams passed out of 6. So what's the probability they pass exactly 3? This would be probability y equals 3. If I use the formula that we talked about in class, 6 choose 3, the probability that they do pass the exam is 0.86 to the third times 0.14 to the third. If they pass 3, they don't pass the other 3. Probability of success, probability of failure. Now, in the calculator, I could type this in, or it's the same as doing binomial PDF with n equals 6, p equals 0.86, and x equals 3, having 3 successes. So I'll go in to show you that. Second vars again, binomial PDF, probability density function. We have 6 trials, 0.86, and 3. So we're looking at a probability of about 3%. 3% chance of them passing exactly 3 of their exams. Okay. So let's take a look at part B. They pass some of their exams. Not as clear. You got to think about what does some mean? Well, some means at least 1. Now, we can take the knowledge that we learned last unit and apply it here. I could do 1 minus the probability that they pass 0 exams. That would simply be 1 minus 0.14 to the 6th. They pass 86% of the time, the other 14% they don't. The other option is I can do 1 minus binom CDF, n equals 10. Nope, I'm sorry, n equals 6, p equals 0.86, x equals 0, which is the same thing as doing this. So again, if I go to the calculator, 1 minus, and I take binom CDF, 6 trials, 0.86 probability of success. We want to subtract away that there's 0 successes, leaving us with at least 1. Now, I just want to take a moment and show you that 1 minus 0.14 to the 6th is going to give you the same answer here. Because essentially what I've done, 0, 1, 2, 3, 4, 5, 6, I want these probabilities. If I find this probability, say it's 0.2, it's not, and then do 1 minus that, that gives me this probability. So here, this probability is 0.999, couple 0.9s. Very, very high likelihood that they pass at least one of their exams. All right, moving on to part C. They pass no more than 4 exams. No more than 4. So now we're looking at less than or equal to 4. Well, I guess I use the random variable y. Less than or equal to 4. So I'm just summing up 0 through 4. Because I'm starting at 0, I don't need to do a 1 minus. So this is simply going to be a binomial CDF. N equals 6, P equals 0.86, and X equals 4. because this x equals 4 sums up the probability of getting 0, 1, 2, 3, or 4 successes. I'm not going to bother showing you how to plug that in the calculator. I think from the previous parts you understand how. I hope you do. Moving on to part D, they pass more than half of their exams. More than half. Y is greater than 3. So now I'm back to this idea of I'm not starting at 0. More than 3 just means 4, 5, or 6. So I need to get rid of everything below that, the 0, 1, 2, and 3. So I'm going to do 1 minus binomial CDF. N is 6, P is 0.86, and X is 3. Because I need to get rid of everything 3 and below, leaving me with just 4, 5, and 6. That's why I'm using this idea of the complement. And in part E, how many exams should they expect to pass? So this is just a formula on your green sheet, N times P, which makes sense. They take 6 exams and there's an 86% chance of passing one of the exams. The product of those is just going to be how many exams on average we expect them to pass. So 6 times the 0.86, 5.16. So we would expect them to pass on average 5.16 exams. So I hope this was helpful and it gave you an opportunity to practice the skills, especially the calculator work that we did in class on Monday and Tuesday. Hope you have a great day, and I will see you next week.